Hi, I'm Alegre and I'm going to present SelfieArt, interactive multi-style transfer for selfies and videos with soft transitions. Imagine that you took a beautiful photograph like the one shown here. What would this photograph look like if we transfer the style of a famous painting to it, such as the Starry Night from Van Gogh? Well, the photograph now looks like it was painted by Van Gogh himself, but it still preserves its structure and main elements, like the buildings. And now, what about if you used another painting from different artists? Well, this kind of results can be achieved since the remarkable work of Leon Geddes on neural style transfer. The key idea here is that we can separate the content and style of an image using a convolutional neural network. Since then, faster methods have been developed, allowing for style transfer in real-time applications. They have also been combined with semantic segmentation models, where it's possible to transfer the style in predefined segments. It is well known that selfies are the basis of many social network interactions nowadays, such as Messenger, Instagram, Prisma, and Snapchat, where it's possible to play with filters and special effects. Also note that semantic segmentation models can also be applied to faces. In this sense, the semantic segments can be the hair, the clothes, the background, the eyes, and so on. In this context, we propose SelfieArt, an interactive multi-style transfer method. With SelfieArt, user can select the desired segments for which a given style must be transferred to. While so, the user can control the smoothness in the transitions at boundaries of the segments. Next, a different style can be applied to another set of segments, allowing for simple and creative exploration. SelfieArt, however, is not limited to portraits. SelfieArt can also be applied to videos. Here, the style is applied to each individual frame while preserving temporal coherence. Our contributions include a technique for interactive multi-style transfer of portraits and videos, which is based on semantic segmentations of facial elements, where each facial element may receive a different style, and a method for blending the multiple styles with adjustable softmasks. They are built from probabilities provided by the segmentation network, and can be adjusted by the user in real time. Next in my presentation, I'm going to introduce the SelfieArt pipeline, the face parsing and neural style transfer methods used, and our proposed parameterized softmasks. Finally, I'm going to show results for selfies and videos and present the final conclusions. Given a selfie as input, a face parsing neural network performs semantic segmentation of the facial elements. From a set of style images, a style transfer algorithm can be used for style extraction. The user then interactively associates the styles to the segment elements of the image. For instance, style A can be applied to the clothes, the style B to the face elements, and style M to the background. The user also defines a desired smoothness level, which is used to create the softmasks. The softmasks avoid abrupt transitions between stylized regions, which would be introduced if regular binary masks were used instead. By combining the selfie and the styles using our proposed softmasks, the result is a selfie with multiple styles and soft transitions between stylized regions. The same process applies to the case where the input is a video selfie. Then the style is transferred to each frame individually, and the result is a stylized video selfie. The goal of face parsing is to assign a pixelized label for each semantic component in an input face image or video frame. A matrix ZK is generated for each semantic segment K in the image. These matrices are later interpreted as probabilities of each pixel belonging to a given segment. In this work, we use the bilateral segmentation network, BiSNet. BiSNet combines a spatial path, which preserves spatial information and generates high-resolution features, and a contrast path, with fast dose sampling used to obtain a large receptive field. These characteristics allow BiSNet to perform semantic segmentation in real time. The model was trained with SelfieArt, a large-scale, high-resolution face dataset with fine-grained mask annotations. In this dataset, there are 19 semantic segments including background, skin, hair, eyes, nose, and clothes. The key idea of neural style transfer is to separate style and content of an image using a convolutional neural network. Given an image C and a style image S, a stylized image G is generated. This is done by minimizing a loss function composed of two auxiliary losses, one to preserve the content and one for style transfer. The two auxiliary losses are rated by parameters alpha and beta, which controls their respective importance. The content loss is defined as the mean squared error of the activations in the feature maps from a pre-selected layer of a pre-trained convolutional neural network. Here, A denotes the matrices of the activations in the feature maps of the layer L. Intuitively, when two images produces similar activations, it means they are similar in content. The style loss, in its turn, is the mean squared error of the Gram matrices given G and S. The Gram's matrix measures the covariance between features in space. In other words, which feature maps tend to activate together. This way, it captures color and texture information, not affecting spatial structure, which is preserved due to the content loss. SelfieArt employs multi-style generative network, MSGNet, a feed-forward neural network that runs in real time. MSGNet generates a stylized image G with a single forward pass given any content image. It learns to match the Gram matrix of the style targets during training. It was trained with the COCO dataset and a set of 21 different style images. Given U, which is the set of the semantic segments selected by the user to undergo stylization, a soft mask MK is generated for each selected segment. A final mask M is then created by combining the masks of all desired segments. Finally, the resulting image O is the alpha blending composition of the original image C and the stylized image G, using the soft mask M shown before. But how each mask is constructed? We introduce parameterized soft masks by scaling the outputs ZK for each segment using a single scalar parameter tau before soft masks. Tau controls the amount of contribution of the pixels for which the face parsing model is uncertain about. When tau is less than 1, it smooths the softmax, raising the output entropy. When tau equals 1, it recovers the original softmax. As tau goes to infinity, it approximates a binary mask. In this example, the stylized regions include all segments except for hair, eyes, eyebrows, and lips. Note that for low values of tau, the values in the mask for the selected semantic segments are more uniform. This results in all pixels being partially stylized with similar blending factors. Note that the hair is being stylized even being not selected. As the value of tau increases, the mask's values for the pixels in the user-selected semantic segments increase. For instance, for tau equals 2, the mask becomes more similar to the binary mask, but still presents difference for the pixels near the boundaries of the segments. This makes the transitions between stylized regions become more natural, avoiding abrupt transitions. Here, we show this effect in more detail. Observe that the binary mask produces a natural, abrupt transitions at the boundaries of the stylized regions. For tau equals 1, the stylus exceeds the face segment and is also applied to hair with low intensity. The user can continuously adjust the value of the smoothness parameter in real time to create the desired effect. We now present some additional results using SelfieArt. Here, we show the use of two-style transfer to create artistic portraits. Each portrait combines the styles from corresponding rows and columns. The possibilities of creative exploration are only limited to the user's imagination. With SelfieArt application, the user can select the selfie regions to apply the desired style, control the smoothness parameter, and then select a different style to transfer to another part of the selfie. The user can repeat the process as many times as desired, all in real time. Now we are going to show some video examples demonstrating several combinations of styles. Introducing Mr. Obama.
Hi everybody. Anaya, thank you for that beautiful introduction. Hi everybody. Anaya, thank you for that beautiful introduction. Hi everybody. Anaya, thank you for that beautiful introduction. Hi everybody. Anaya, thank you for that beautiful introduction. Hi everybody. Anaya, thank you for that beautiful introduction.
In conclusion, we presented an interactive technique for performing mood-style transfer for portraits and videos. Our method provides a simple and intuitive way of producing exquisite artistic results that smoothly combine multiple styles. Its flexibility, speed, and quality of results allows for creative exploration. We would like to thank our sponsors and everyone that helped us with this work. The source code for SelfieArt is available on GitHub with the following link. Thank you for the attention.